Okay, fellas who are tuning in on YouTube right now, please make sure that you have opened the slides that were sent by the organizing team, right? Open the slides, follow the pre-coding preparation if you like to code along. Otherwise, you can, spend the next 1 to 1.5 hours listening to me speak in my deep voice. Not sure if it's deep, but yeah, listening to me speak and watch me as I code. So once again, please check your email for a deck by the team and follow the pre-coding preparation if you like. Okay, 7:05. Let's begin. Okay, I'm good. Thanks, Jianhui. Present. All right. Good evening, everyone. My name is Jackie, co-founder and CEO of Uplevel. And this evening, thanks for making time for this session. We are going to use computer vision for object detection and counting. Okay. So about myself, a little bit about myself. Who starts a workshop without the obligatory self introduction, right? So I wear many hats, and I got I'm alumni from NUS class of 2012, so I'm a bit of an old bird. Subsequently, I went over to NTU to do a PhD in applied data science. Okay. Now after that, during my PhD, I was doing a startup called Fund My Life, or FML for short, which I got Forbes 30 under 34. I speak in TEDx. In fact, I think I was speaking in TEDx NUS 2 years ago on student entrepreneurship. Subsequently, I sold my company 2 years ago, and I started Uplevel. So what Uplevel does is that we help we help we help people, we help coders, aspiring data scientists such as yourself, get better in data science and also build a portfolio with our projects. So if you receive the slides, take a look. We have 3 projects right now. They're up for grabs. Probably gonna end tonight. So if you haven't got 3 projects from our site, you're missing out, bro. Okay. So why are you here this evening? A few questions, right? So you might be a noob, right? You're curious. You're here. You're joining this competition to learn more about coding, deep learning, and also computer vision. So as a beginner, it might seem overwhelming, which is also why you're here with me, listening to this, and also hopefully pick up some practical skills, which you will, because this is a code along. All right, code along means we I code, and well, you can watch, but ideally I hope you code along as well. For intermediate learners, you might be curious about what I have to say in a workshop like this. And then you have the experts who want to win. Actually, I don't expect the experts to be here this evening. They might be doing other things. But regardless, um, learners of all skill levels, welcome this evening. Learners who are just beginners, no problem. You will pick up computer vision. You will understand what it means to use the different methods found in computer vision library. Intermediate learners, if you're gunning for a top position, I will be dropping hints. Once again, I will be dropping hints. So if you hear me pausing or pronouncing things oddly, okay, not that oddly, perhaps my enunciation changes slightly, it might or might not be a hint, all right? It might or might not be a hint. And if you stay all the way to the end of this evening, I just might drop a few more hints on how to tackle the challenge. Maybe, maybe not. Who knows, right? Okay, I shan't say too much because the organizing team might just cut me off from live. But anyways, welcome, welcome, welcome. It sounds like Vanakkam, Vanakkam, Vanakkam. The agenda for today, of course, we code along using Python and computer vision to detect objects and count objects. But before we do that, let's take a quick, a brief intro to what object detection is. Right. So this is one of my favorite memes. You want to take, you have an image, you want to use computer vision techniques to identify what it is in the picture. So in this case, it's supposed to be a cat. Humorously, it says it's a dog. Ideally, it should say cat. Object counting, you want to count objects in an image, right? So in this case, we are counting the number of free spaces. And because when we draw boxes around here, we are trying to detect something. And when we've detected other objects other than this circle over here, we just say, hey, it's taken, okay? So pre-coding preparation, before this video started, before this stream started, I mentioned that all of you should do this pre-coding preparation. There's a zip file with images for you. So these images actually come from a separate tutorial, which I will be sharing at the end of this course. I think even though whatever I'm sharing, right, is, yeah, I think all these object detection tutorials, whatnot, right, they're not unique. You have maybe tens and tens of articles saying the same thing. But hopefully with me this evening over here, I'd be able to maybe help dissect or even, how do I put it? To elaborate and explain the importance of each function and methods used. Okay, so ideally once you set up your folder on your Google Drive, right, you shall see this NUS Stats CV Workshop 2021, the frames, right? 616, I actually don't sleep much. And you have 116 frames over here, okay? Even though it says 117, it's supposed to be 116, so my bad. So without further ado, it's party time. Let me just stop my share and go straight to the folder, right? Let me just take a quick peek at, okay, no problem. All right, so I am going straight to the folder, right? And this is what you saw earlier on in the image. So what I like to do right now is to start a new collab over here. Just give it a wait. Just give it a wait. Okay, I'm just gonna call this workshop stuff. Okay, workshop stuff. Before I start, you'll have to connect over here, just so that you're connected to Google resources and you can perform your computer vision stuff, right? Okay, so I'm just gonna zoom in a bit just so everyone can see stuff, and then from there we're good. I'm just gonna maximize my screen, right? So feel free to minimize or rather change the size of your window and cut it at the half just so you can see the code top half. Imagine, let's say if you're coding at the bottom half, you can do that too, right? Now, if I stop oddly at certain places, it's also because I am referring to my notes, okay? So without further ado, let's begin. So I'm going to import libraries first. I shall import OS. I shall import RE. So RE helps with regex. Import. So we'll be importing computer vision library CV2, right? So this is the open CV library. CV library, right? Next, we will import NumPy as NP. Now, NumPy is very important because we'll be using it quite extensively later on. Now, from os.path, import this file join. So we'll be doing some list manipulation later, and it'll be useful to have these two. And finally, we will import matplotlib.pyplot as plt. Okay, so this is all we need for now. And with these 6 libraries, we are all set. Okay, so once again, 6 libraries. So next, first we'd like to get the file names of all the frames in our image folder. So let's go to files. Now, what we want to do is to go to that Google Drive folder containing the 116 images. But before that, we need to mount our drive. So let's mount our drive, and Google will ask you permit this notebook to access your Google Drive files. Of course, you say yes, because no one says no to Google. Let's give it a wait. It's mounting right now. So for myself, I have many gigabytes of files. Yours, not so much, probably. It may take a long time to complete if a large number of files, guilty as charged. Let's just wait for a bit. Okay, so try refreshing. Refresh a couple of times in frustration, in anger. Okay, so the anger did the trick. So I'm just gonna navigate to the file, no, to the folder containing my images. So I'm just gonna scroll down to, okay. So I'm gonna scroll down to NUS Stats CV Workshop 2021. So this is our notebook right here, and this is the frames. So we will copy, okay, let's show you what happens when you open the frame. So you have all your images over here, right? So I'm gonna right click, I'm gonna copy path, okay? So copy path over here, and we close this for a while. Now, call frames, so we just declare path for frames. Call path equals to, oh wait, sorry. Let's declare a list containing the frame names equals to os.list directory in your in this particular folder right here. Now, if you do this correctly, when you run this, right, you will see that the list is a list containing all of your images inside. So you have 2.png, so on and so forth. Now, what do you notice about these guys? These guys, they are not ordered. So we want them to be in an order. We want them to be ordered, right, from 1 all the way to 116 or so. So what I'm gonna do is I'm just gonna remove this because we just wanted to check it, right? Check it. Right, so here we have a variable called coframes that contains a list of all the file names within my frames drive. Okay. Now let's do a sort. Let's sort file names. And to do that, we do call frames.sort. So we'll use a lambda function. So lambda function, if you're not used to it, it's just a function that you can call instantly. And what we're going to use is the regex library. So we're going to substitute. We'll sort everything in our list. If you're kind of lost at this stage, don't worry, just code along. Usually, you can find the same things over here when you go to Stack Overflow. Okay, so don't worry. Now, when you do that, after you do the sorting, once you go back to, so I'm gonna run coframes again just to see what happened here. Wow, what have I done? Look, initially it was 2.3.png, whatever, so on and so forth, right? But right here we have everything in its sequential order. Of course, you are missing maybe 1 or 2 frames, but actually it doesn't matter. Okay, doesn't matter. As long as your coframes are ordered correctly, it's all good. So once we're done sorting, right? Once we're done sorting, give me a second. Let me look at my notes. Sorting. Now we shall create an empty list to store the images. So create empty list to store images. And to do that, I'm gonna do call images equals to this. Okay. For frame in call frames. So we'll look through the list of file names we have in there, and we're gonna read the frames. Okay, read frames. Temporary image is equals to cv2.imageRead. So cv2 image read. And what I'm gonna do, right, is I'm gonna hit back to the top, and you see this string over here. I'm gonna copy the string over here. I'm gonna copy the string over here. I'm gonna paste it here, right? But what I like you to do is actually add an additional slash at the back. Once again, add an additional slash at the back. I'm gonna add frame, okay? So if you do that, right, when you print, okay, wait, you shouldn't print that. So right now, what you're gonna do is it's gonna look through the list of images, image file names found in call frames, and you're then going to iteratively read the image, right? And then what you're gonna do next is you're gonna append the image, the temp image, into the list of images. Okay, so call images dot append temp image. Okay, so we let that run for a bit. While this is running, let me just skip over to YouTube to see if there are any questions so far. Okay, so it's still reading. Goodness, it's very long. Also, by the way, if you guys are wondering where are all these files, right, please make sure you check your email. You know, hey, guess what? I'm an old man, right? And an old man has the right to complain. Kids nowadays don't read their emails, I must say. Poor hardworking stats folks toil and send emails to all of you, but you guys just leave it in the promo tab. Very cruel. So I'm just sipping my tea right now, waiting for the images to be read and iteratively added to the list. It's gonna finish anytime now. Okay. Okay, it's done. Guys, my co-founder, she says everyone is insanely downing the free notebooks. Thank you for your support. Look, if you like our free notebooks, please join us and our community. Okay, we are an amazing community of data science learners, and you know, imagine monthly access, regular access to me, right? We have cool things like fireside chats with AI Singapore, for example. That's happening this Wednesday. Anyways, enough about that. Let's continue, right? So I'm just gonna let everyone run their thing a bit more, and then I'm gonna continue. Now, if you take a look at your list of, if you take a look at the list right now, so core images, let's take a look at the first item, okay? Take a look at the first item in core images. At core images square bracket 0, you will realize that it's, hey, what is this? What's this? This is an image, okay? Because images are nothing but binaries. Okay, this is not exactly binary, but a series of values, okay? So here you have a series of values. We will visualize our image later on, but the core idea is that our images are nothing but numbers stored in matrices, okay? Now let's take it one step further. Let's take a look at the shape. Now, where images, right? It's important to take a look at the shape. Once again, for images, it is very important to look at their shape. You want to know whether these images have the same sizes and dimensions. Okay. I'm saying slowly, maybe because it's early onset dementia, but it could be alluding to something very, very important. Okay. Co-images. So here we have, what are we looking at here? We are looking at the width, height, and the number of channels. Because the image, if you had the chance to look at our image, you see that it's actually a colored image. It's a colored image, and the dimensions are, you have the height. Okay, sorry, this is height. Height 144 pixels, 256, and 3 channels, which means it's a colored image. So you have 3 over here to denote that it's a 3-channel image. Okay. Now next, what do we do now that we've seen the numbers, we've seen the shape? What we're going to do is we're going to plot the image. So let's plot the 15th frame. Okay, I don't know, it's a random image. Okay, if you want to go a full Lamau 69, that's fine with me. Okay, I'm just gonna go with 15. Okay, 15. It's, so I'm gonna go with num equals to 13. Okay, num equals to 13. Oh no, not 13, sorry, what am I saying? Num equals to 15, right? Now for frame, so I'm gonna show you guys 2 frames. Okay, guys and girls. 15, oh no, sorry, I num comma num plus 1. So I just want to see both frames. Okay, so num plus 1, and what I'm going to do is plt dot image show, right? Image show cv2 dot cvt color, cvt color bracket, call image just frame cv2 dot color underscore bgr. Hey, BGR doesn't stand for boy-girl relation, okay? BGR stands for blue, green, red. Now we're used to the whole like RGB, right? But hey, do you guys watch Startup, right? RGB. I'm actually team Han Ji Pyong. Anyways, so BGR in OpenCV, right? The colors are organized as blue, green, red, not red, green, blue. So this is important because, this is important because if we are using color-based techniques in computer vision, you must always remember to flip the values around. Okay. If you were filtering for a particular color and it does not seem to be that you're filtering for the right colors, don't forget it is BGR and not RGB. Okay, so BGR to RGB. Okay, what we're doing is just we're changing the color so that it's suitable to show you using the matplotlib library. Okay, PLT, because if you don't flip your images. Okay, so I guess it's a good time to also explain what this is doing, right? OpenCV's library, CVT color changes the color channels in your image. So we're changing 1 frame at a time, and we're changing it using this particular thing over here, which is return from BGR to RGB. Okay. So OpenCV, actually, it's a pretty relatively straightforward library to use as long as you know what you're using. Okay, so I'm just gonna do a quick frame over here, and then I'm gonna go with plus string. Okay, string frame, and then finally I'm gonna do plt.show just to show them sequentially. Voila. Okay, so frame 15 and frame 16, it looks like nothing's changed, right? Look at that. It's actually not a lot of difference. So of course, before I go on, what we're looking at here, what? Two frames, where vehicles are moving. Now, um, because of how close the frames are, we actually can't tell the difference between these two images, right? So what we'll do, right, is we'll first convert our images to grayscale, okay? So we want to see what's the difference between these two images over here. And for that, we shall convert our images to grayscale just so we can see the differences later on. So convert the images to grayscale. Okay, so gray A equals to cv2.cvt color bracket col images. Okay, col images num. Okay, comma cv2 dot color underscore bgr2 gray. Okay, so color to gray. So we're gonna turn our image to gray, right? So we shall copy this entire line, go to the next line, and just change the image around. Now, don't forget num must be num plus one. Okay, so take a quick look at this, see if there's anything up. So first thing, gray, change color to gray. Gray B, it is num plus one, also gray. Okay, so once we've done this, we shall get the difference. So we'll what we call frame differencing. So plot the image after frame differencing. So you'll see what frame differencing means later on. Okay, so plt dot image show bracket cvt2 dot absolute difference between the second image and the first image. And what I'm going to do is turn the color map into gray. Okay, so plt.show. So just gonna let it sit here and let it sit in, right? See what you guys thought of this. What happened over here? What happened? First, we've turned the images into grayscale, and then what we did is we subtracted the second frame, which is frame 16. We subtracted we subtracted 15 from frame 16. So we're actually seeing the difference. Now you can see that the difference is that the car moved from this position to this position, right? If you go back over here, you see that the car actually moved from here to here, right? Car moved from here to here, and then here actually moved a bit slightly only. That's why you can see minor movement. Okay, so you might be wondering, okay, so what, right? So what I'm gonna do is I'm just gonna go ahead and save the diff into a variable. Do is save it. I'm gonna declare a variable called diff image equals to. I'm just gonna copy this guy over here. Right, I'm gonna copy it over here, and then so next, right, what I'm gonna do is do this thing called image thresholding. Now what I'm doing is that I'm finding the threshold of the image, the differences over here. So when my, okay, a bit of background explanation, right? So how do we know that an image is moving between frame to frame? No, sorry, how do we know that an object is moving between frame to frame? We want to see the differences. We want to see the differences between frame 16 and frame 15, correct? And so we do a subtraction. Now, over here and here, does it move? Does the grass move in between frames? Okay, I can imagine you guys saying no, right? In the background, does the pole over here move, in reference to the frame before that? The answer is of course no. So when you do a subtraction, right, all these stationary things will be subtracted away. So you can actually have all this darkness, right? The whole thing darkness here means frames, the second frame and the first previous frame. So we'll do an image thresholding just so to give this shape over here to tell you, hey, this thing actually is an object. This thing over here is an object. This thing over here is an object, so on and so forth. So, okay, let's do that. So let's perform image thresholding. Okay, and then what I'm going to do is return thresholded image cv2 dot threshold bracket diff image. I'm just gonna go with 255 and cv2 dot thresh binary. Okay, well, I'm gonna plot your thresh first and show you what I'm doing. So image after thresholding, plt.inshow bracket thresh, comma, cmap equals to gray. So I'll give you all some time to okay, show. Yeah, plt.show. Okay, now what's thresholding, right, is that when you look into, sure, we actually detected a lot of things, right? Like these things are actually objects, but notice that we're also detecting things like shadows over here. Now we don't want shadows, right? We don't really want shadows. Then the reason why we don't want shadows is that if we were to draw a box around, let's say if we tell OpenCV, hey, draw a box around something that has, that is not black in color, you will end up drawing a box that's actually larger than the car. So you want to get rid of these images over here. So you want to just keep high signals. And you can keep high signals using thresholding. So by thresholding, you're actually keeping, you see, notice that all of these guys here are gone, right? So anything that has high intensity will be turned into binary. So this thresh binary means if it's above a certain range, if my pixel intensity is above a value of 30, then I would automatically switch it to the max, which is 255. That's why even for soft colors over here, right, you will get maximum intensity over here, so on and so forth, and the rest of the friends over here. So that's what thresholding is, okay? Threshold helps you, think of it as a filter, to filter away low intensity things, and then to attenuate high intensity stuff into ultra bright signals. So that's the power of thresh. Of course, please read up on the different kind of thresholds that are available. So instead of thresh binary, you can have thresh. Yeah, okay, yep, that's okay. Binary is good for black and white. It's better for complex images. Haha. Okay, anyways, back to, so threshold will help you filter the noise. But if we just draw boxes over here, right? If we draw, we might end up drawing multiple boxes around our object simply because the lines are not exactly connected. So what you want is you wanna like decrease the resolution of the image. And how we do that is we decrease the resolution of the image by using image dilation. Reduce resolution using image dilation, okay? So we'll first declare a kernel. So what a kernel is kind of like a mask to run around and, okay, wait, let me think, what's a good analogy of it? So imagine your talented older brother or sister drew a very nice painting, right? And you, out of in your fit of jealousy, decide to take a sponge and rub that sponge all over. Do is you do a circular motion around your painting. Try to imagine it. You do a circular motion across your image. What happens to the image? It still retains the quality of the image of the painting that your sibling has painted, but it becomes a murkier, a blurrer version. Okay, a blurrer version of the image. So we will do that using image dilation. So np.1's 3,3 will be using a 3,3 filter and declare that this is a, so this is a int 8. I mean, numpy is here for to speed up a calculation, right? So put it here. Then dilated. So we shall dilate the image next by applying the kernel across it. I mean, you can Google what kernel is. Of course, I use a very lame explanation for it, but kernels are fascinating and kernels are very useful in other parts of what's that, deep learning, right? So dilation, you take the image that you got from here, you apply a kernel over it. So it's you taking a sponge, rubbing all over it, and then you rub it over it once. Of course, we can try out more than one iteration later on, but let's take a look, see what's up. Okay, so let's plot. So let's plot the diluted image first. Same thing, plt dot image show bracket dilated, comma, cmap equals to gray. Okay, and then of course we do plt dot show. Oh, what happened? Oh, iterations equals to 1, sorry. Oh, what happened here, guys? What are we seeing here? What happened? Remember what I talked about resolution, right? So imagine if this, you took a brush and you like, your sponge, you took a sponge and you rub the sponge all over that image of yours and you just rub the pixels all over, you get something like this. Of course, if you do iteration equals to 2, you get something like this. What do you notice? The more you scrub, the blobber it becomes, the more dilated it becomes. It becomes this like blob, okay? So once again, blob, blob. So notice that there's a boundary between here. Okay, when you dilate your image for object detection, you will need to tune the iteration and the kernel that you use for dilation. The reason for that is because the higher the number of iteration, boundaries will decrease, will disappear, and by the time you reach a certain number, you get a blob. Okay? Hint. And of course, your kernels are important as well, because let's say if you do a 4-4 instead of a 3-3, you get something like this. If you do a 5-5 rather than the 3-3, you get blob. So again, dilate wisely, dilate carefully, and dilate like an experiment. Okay. So do we detect all of the images over here, right? Do we detect all of the vehicles over here? No, we don't. We shouldn't, and we try not to. So instead, let's just plot a vehicle detection zone. So let's plot a vehicle zone. And to do that, we shall plt.imshow dilated. So we'll show the dilated image first. Next, we will draw a line. This is drawing a line actually. So C2.line bracket, right? Dilated, comma. So I'm gonna type in the coordinates for the line. So we start off with the y-axis. Then we'll start off with the x-axis. Don't ask me why the syntax is like this. It's yeah, such is life. So this is the thickness of the line. Yeah, depends on your preference on how thick you want the line to be. Myself, I got the thickness for the thickness. I'll go with 256. All right, so let's go. There we go. Okay, run it a couple of times, you shall see it. This is the zone where, so this bottom here, okay, we'll be using this bottom zone to detect the vehicles, right? So this is just to delineate the lines over here, okay? Okay, now I'm a bit worried about my statement about having the thickness for the thickness. Please don't cancel me, friends. This is a genuine expression of, anyways. Okay, so now that you've seen, okay, we have thresholded our image. Oh wait, we first obtained a difference for our image. We then thresholded to filter. We then dilate it so our images are more blobular. I have no words for this. Blobless, blobular, bloblublo. So next, we then drew a line to denote the boundary. Next, what we're going to do is we're going to draw a contour. Now, what are contours? Contours are just outlines. Now, if you take a very close look at the at your plot over here, do you see this green over here? Right, that's presumably the contour of your the outline of your object, right? So let's draw an outline for our objects over here. We shall find contour, 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 right? So contours, comma, hierarchies. So I can't spell hierarchy. Okay, so equals to cv2 dot find contours. So this is useful if you are using a particular this technique to find your acumen, right? You'll be contouring stuff, maybe, who knows. Recursive tree, cv2 dot chain approx none. Okay, what's happening here? What's happening is that you are putting in a copy of your original image. It's actually good practice to use copy because you don't want to mutate. I mean, in Pythonic terms, you do not want to mutate your original data. Really, you don't. Instead, what you want to do is copy it so that all is good. Then the subsequent two are more or less just algorithms used in drawing the contours. Okay, so let's run that. Hopefully nothing bad happens. Indeed, nothing bad happens. Now, what I'm gonna do is maybe just show you what happens when you draw contours all over your image. So what I'm gonna do is temp copy equals to call images, right? And I'm gonna do 15 because originally it's 15 dot copy. Okay, got copy. Now, what I'm gonna do next is I'm gonna do cv2 dot draw contour temp copy, and I'm gonna do contours. Okay, I hope this works. -1, comma, the color of my contours and the thickness of the line for the contours, cv2 dot line. Okay, temp. Okay, wait, let me run this first. Let's see if this works. I draw contours. Okay, go. Wait. Oh, my bad. Sorry, friends. plt imshow temp copy plt.show go. Yeah, what's going on? I've drawn contours all over, right? Now, is that a good thing or a bad thing? Bad thing. It's a bad thing. It's a horrible thing. Why? Because I am indiscriminately detecting the contour of every single image in here, right? Of course, you've found the moving objects, but they're not what you want. They're not what you want. You want to detect them beyond a certain range. Now, this is where I introduce the idea of a bounding box. Okay, a bounding box. Okay. Wait, let me check. Let me check what time it is right now. Okay, we still have time. Good. So what we need to do is actually to collect only the valid contours. So declare list of valid contours. Valid contours equals to for I contour in enumerate bracket contours. So what you're doing here is that when you enumerate, you're not just looping through the item, you're also getting the index. X, Y, weight, no, why am I saying weight? Width, height, CV2 dot bounding rectangle contour. So what we will generate here is actually 4 coordinates. When you do bounding rectangle, right? You're drawing a rectangle. You're using a rectangle to draw. So you're creating a rectangle based on your contour file over here, and you will generate 4 things: your X position, your Y position, your width, and the width and the height, right? So I'm just gonna go with if bracket, right? X is less or equals to 200 pixels, and Y is more or equals to 80, and and so many ends, CV2 dot contour area contour more or equals to 25. You will then append that contour into the list. Now, what am I doing here? I am checking if whether my contour, right, using the bounding rectangle. Once again, I am using a bounding rectangle, which may or may not be a shape that you recognize in this week. Ha, ha, ha. You're using a bounding rectangle on the contour, and you're checking for its position, and you are checking for the area within a certain size. Only then do you append that contour into that that list of contours. Okay, who knows, if you set things correctly, you might actually be able to count the number of contours in that frame, and nowhere else. Okay, ha 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 ha. So check length of list, check length, check. Wow, I can't spell. Right, so length of valid contours. Haha, what's going on? I have 7 contours over here. Yeah, so that's that. So let's redo this. Let's do a quick redo. I'm gonna copy this guy over here. I'm gonna copy, and then go paste. And what I'm gonna do in between is I'm just gonna add enter over here, and I'm going to do I'm gonna change a few things over here. I'm no longer gonna use contours. I'm gonna use valid contours. Okay, and next I'm gonna draw that same line which I drew. So I'm just gonna go back up here. I'm gonna go back up here, and I'm gonna copy this guy over here and go back down. Guys, don't type out the entire line. You've already typed it. Don't do double work. Go back up, copy CV2 dot line, go back down, paste it. Now, of course, you don't do dilated. What you do is CV2 dot line. You will do temp copy. Okay, temp copy. 80. Okay, this one will change the values a bit. So it's 100 and 255. This is the color. It's just the color of the line. Okay, in this particular tuple, you can do anything you want. Okay, but coordinates is a must. Okay, so fellas, take a moment, see if everything's correct, plot it, run it, and check it. Okay, of course this isn't done perfectly because the contouring it's not, it's, yeah, okay, let's not sweat the details. Right, I've get with more refinement and time, you'll be able to contour it better. Okay, again, with more detail, experimentation, and time, you'll be able to contour it better. Okay, so that's that, right? That's that. Do we have time? Yes, we do. Okay, let me just do a quick check in YouTube to see what everyone is saying. Uh, so someone asked, does one have to do all 29 steps to get to the contouring stage? Answer is yes. Haha. So a guy named Python Master asked how to understand dilation. Guys, I just gave a wonderful imagery of what it means to dilate, right? Like, there's a painting and then you take a sponge and you just rub all over the painting and smudge it, right? Let's see, how do we know which is the optimal iteration? The optimal iteration is it's a lot of trial and error, actually. Everything is trial and error. CMAP, let's see, will you cover other object detection libraries other than CV2? Haha, no. Shit. Hey guys, big, huge shout out for everyone who's answering questions here, right? Thank you so much. Thank you so much for helping me answer. I really can't go back and forth. I'm horrible. This is quite meta, isn't it? Me looking at me, right? Okay. Anyways, back to work. Okay. Now that we've done each piece by itself, so what have we done? Let's do a quick review. We did a threshold to remove shadows. We then did a dilation to kind of like smudge these guys into blob, reduce the resolution so that it's one blob, so we can detect it as a single object instead of multiple squares or whatever. We then drew threshold across when you realize, okay, there's too many and maybe we should just set an object detection zone over here. Now next, after we've done that, we can actually put everything together. We can put everything together. So what's gonna happen is a series of copying, okay? What's gonna happen is, okay, is it a series of copying? Maybe, let's do it. We have time. So, so what I like all of you to do, right, is to copy. Step 1, copy kernels. Step 1, copy kernels. Instead of 3, we'll do a 4. Then we will then declare a path in. So we'll declare a path in, right, so that we can. Okay, I won't spoil the surprise, but we'll declare a path in to save the output frames. Okay, declare a path in to save the output frames, and so path in equals to. Now, go back here. So we will. Over here, right, I will need you guys. So click on your original. So on the top level here, right, I'll need you guys to right click. And what I need you to do is to create a new folder. Okay, and the folder, right, we're gonna call it output frames. Okay. So once again, go to your folder name over here. You press right click. You should see that everything over here, and you create a new folder, and the new folder output frames. Okay, this is where we will save our output frames. So copy path, add a slash to the back. So make sure you have a output frames like this. Okay. So next, font. We'll declare a font as well. So font equals to cv2 dot font Toshi simplex. Okay. So let's do this tree first. We will be declaring the kernel. we'll be declaring the path in. So again, create a new folder. Later on, if you encounter an error, it's because you don't have your folder over here. And finally, you'll declare a font over here. Okay. So for I in range length of column image -1. So what we're doing is look through all images, do frame differencing. Okay, so how do we do frame differencing? Is what I'd like you to do is scroll back up and copy the thing that you've already done. Okay, so first we did all this right just so we can, enjoy this guy over here. So scroll down. Okay, do frame differencing. So instead of co-image num, just right. So I plus 1. And then what after that is you might have guessed it. So we will get the difference, which is diff image equals to cv2.apps diff bracket b comma gray a. Then what you're gonna do is do image thresholding. Yeah, actually, you know what? So we'll be going up and down to actually copy the stuff that we've done. Okay, so thresholding. So scroll down. So what I've done is I take what we've typed earlier, do thresholding. Such is the nature of coding for stuff, right? Because you want to do it for a small number of examples first before looping through the entire data set. Image dilation, right? We shall dilate the image after this. So scroll back up again. Guys, we're going to be scrolling up and down, so make sure you're used to it. So CV2, dilate trash kernel. So, okay. Right. So kernel, we have defined it previously. Where is it? Yeah, kernel is here. Kernel, trash comes from here. Iterations equals to 1. Next, we'll find contours. Okay, of course, we'll find contours the same way. We will just do, there we go. Okay. So do contours, paste. Next, we will find the contours which are legit. So we go back up here. We go back in here. Get list of legit contours, right? So we'll do a bit of editing over here. Now we'll add a few more lines to it, fellas. So if y is small or equals to 90, and okay, I'm just like typing slowly just so you guys can catch up. Contour area. Okay, contour area is less than 40. So this is a very specific size box that we're looking at, which may or may not help you in your subsequent adventures. Okay. Then yeah, then we don't need this. Okay. Then after that, what we'll do is add contours to original frame. Temp. Okay, wait, let me think. Copy equals to call images square bracket I dot copy. We shall go back up again. So we shall draw contours over our copy. So let's come back down here. CV2, okay. So we don't use temp copy, we just use copy. Valid contours, check, double check. Okay, looks okay. Put text on image. So we'll just say, hey, there's actually how many images, how many cars that put text. Copy, comma, right? So copy. Vehicles detected plus string length of valid contours. So we're gonna say vehicles detected, and we're gonna say how many there are over there. We're gonna put the string position. We're gonna put the position of the sentence. We're gonna declare what font it is. We're gonna declare the font thickness, and we're gonna declare the font color. Okay, so I want it to be green. CV2 dot line. So I'll just draw a line like we did. So copy, comma, copy, comma. Position. Okay, actually you guys can go ahead and copy it from above if you're not confident. Copy 80, 100, 255, comma 255. CV2 dot image right. We got right image, path in plus string I. Okay. I plus dot PNG. It's gonna be copy. Okay, run all this. Oh, co-image not defined. Okay, sorry. Co-images, right? Co-images. I'm such a fool. Okay, right now it's finished running. Oh, that was fast. Okay, fellas. Just gonna do a quick one over here. I'm gonna take a quick look at the output frames. Yeah, see? So my folder contains the output frames. So hope that you guys got it. So once again, whatever that you see here isn't different from what we've done earlier, because this is just the looped version of what we did earlier. Okay, then so what's next? Now that you've created, what I'm gonna do is I'm gonna specify a video name. Okay, then path out equals to. I'm gonna go back to my folder. I'll just copy path my main folder. So I'm getting my main folder over here. Okay, and I'll give my video a name. I'm gonna call it output video.mp4. Okay. Then I am then going to specify frames per second. FPS equals to 14.0. Okay, so this is what I have declared. I'm going to create a video by the name of output video.mp4, and it is 14 frames per second. Okay. So next, what I'll do is I'll just call it frame array. And what I'm gonna do here, right, is I'm just gonna order the files together. So F for F in dot list directory, path in, if this file, join path in. Okay, so this is one of those fancy ways of processing your lists. Feel free to dissect the lines later on when you can, right? So F file for file in the files containing in path in if um, after you join them together. So I mean, technically, you're supposed to just like make sure that all your files are okay. So files dot sort key equals to lambda f int dot sub slash d. So you're ordering the files. So if you check out your files, they're actually now all in order. Okay, they're now all in order. For I, so we're not going to create a video for I in range length files. File name equals to path in plus files I. So you're looping through your files. You're gonna read frames. So what we're gonna do is image equals to cv2.imread file name. And after that, height width layers equals to image.shape. You're getting the shape of your image. Size equals to, you're setting up a tuple containing the width and the height of your eventual video. Inserting the frames into an image array. Frame array dot append image. And then finally, you're going to do an output, which is you're outputting cv2.video writer bracket path out cv2.video writer for cc star dot div x. Wait, okay. No, star div x fps size. Now, what's happening here? You're actually declaring a video writer object that goes to a path using this codec frame rate at this size. So these are all things that we have declared earlier on, right? For I in range frame array out dot write your images frame array I out dot release. So once you're done writing all of the images inside, you will release. Okay, you will then release the video into your directory. So let it run for a while. I'm just gonna leave it here so y'all can. So give it like maybe 30 seconds, and then we have it an output video. So I'm just gonna let it sit there for a while first. Okay, I'm gonna get out this first. I hope everyone's doing okay. Let's see what's everyone doing. Sing T. Don't worry, because earlier on, right, when we use Google Colab, most of the popular deep learning libraries have been pre-installed, so you don't actually have to worry about installing OpenCV. That is also why Google Colab is a great choice, because sometimes when you're setting up your environment for your work and whatnot, there's a lot of intricacies required to install libraries. It can be quite a pain depending on your computer's configuration. But if you did Google Colab, yeah, correct, that's right. So anyways, we are done with the video. Okay, gotta thank Joel. Thanks, Joel. Joel. Workshop stuff. No, I'm gonna go back to my. I'm gonna go back to my what's that? To my folder. Once you're done running, right? Once you have folders over here. Let's see if it's properly converted. Okay, now mind. I shall download. Okay, hopefully this works. Okay, so a bit nervous, but let's see if it works. So output video. Hopefully nothing salacious appears. Oh shucks. Okay, this is bad. Okay, never mind. I think I messed up somewhere. The idea is actually see the live coding then. Hey, don't worry. I just want to show you guys what happens when you do it right. So when you do it right, it's supposed to be like this, okay? I think I messed up somewhere in one of the steps, but don't worry. I believe this files will be sent to all of you if you have signed up with the form that the team sent to you, okay? So on top of a curated list of items to read for your challenge, you will also receive the notebook, okay, the correct notebook, okay? I'll go back and troubleshoot what's wrong. Okay, so okay, I think it's a small hiccup that I think it wouldn't make sense to go back to fix. The reason is because I still have part 2 for you guys. It's a very quick part. It's actually a very, very quick part. In fact, what I'd like all of you to do is open a new Google Colab. Open a new Google Colab. Okay, so open a new Google Colab. Okay, fellas. Shit. I guarantee you this will only take 10 minutes. Workshop stuff, part 2. Okay. So workshop stuff, part 2. Pip install cv lib. So let's run this. So pip install cv lib in a new notebook. So what we're doing here is we are installing a new library. So for those of you who do not know, right, if you're using a Google Colab notebook, you can actually do pip install cvlib. You do pip install cvlib to install new libraries. Okay, but the downside is you have to do this every time you open the notebook afresh. Once again, exclamation mark pip install cvlib. Next, we shall import cv2, import matplotlib dot pyplot as plt, import cvlib as cv from cvlib dot object detection, import draw the box. Okay. So next, import CV2, matplotlib pyplot as PLT, cvlib as CV, cvlib from object detection, dot draw bbox. Okay. Now, I shall go with temp image equals to cv2.imageRead. Okay, because we don't have a lot of time, I'm just gonna go straight and mount my drive. So mount your drive. Oh, my throat hurts. Okay, mount your drive. I've been asked to drink water. Fellas, it's tough when you have to speak all day. Okay. Okay, next, locate your image. We'll use the same image, just grab a random frame, all right? Doesn't matter. So stats workshop, output stuff. Okay, yes. So frames, let's grab 0 PNG, I guess, copy path, right? So copy path. So I'm just gonna grab like one random image from my set. And what I'm gonna do is, after reading the image, right, what I'm gonna do is draw a bbox, comma, label, comma, conf equals to cv.detect underscore common objects, temp image, and the model, we're gonna use YOLO tree, YOLO v3, okay? Yeah, let's do that first. Run it, and the thing will install YOLO v3. So to someone who was asking whether we'll only be using OpenCV, the answer is haha, no. Okay, surprise. I know there's YOLO v4 right now, but this library so far is configured to work with YOLO v3 and below. So just give it a wait while it downloads the wait. Wait, sorry for the wait. Fellas, go. Let's wait for a bit. The weights are actually not small, right? You gotta download everything. While it's waiting, right? Why don't we type out the rest of the code? Let's do this. Output underscore image equals to draw underscore bbox. So we're drawing a bounding box around our temp image. Our temp image, we're also doing it around the bounding box that we've defined, the label and the config. Do that plt.figure. We'll do our figure size to be maybe 6 equals to 16:9. We will also plt.image show output image. We will also then plt.show bracket print number podcast in the image is string label dot count car. So we're counting how many cars there are in the image eventually. So let's do that. Let's wait. Yeah, because I'm streaming and all that shit, right? So it's gonna take quite a while. But you guys might have seen stuff right now. So I'm gonna scroll up right a bit just so those who didn't manage to copy in time can copy. Why is it not downloading? Life is hard, man. Shit. Okay, why is it not doing it? While you're waiting for the weights to download, consider checking out our website at dataprojects.uplevel.work and retrieve your free copy before we actually sign off. We're actually removing it for the night. After tonight, we're removing our free notebooks. It's actually an experiment. Yeah, guys, don't just download the notebooks and not do it, okay? I actually spent a lot of time designing the projects that you see on dataprojects.uplevel.work. We're really passionate about designing projects that can help you up-level yourselves. Oh my god, why is it not reading? Okay, I hope someone else has managed to do it. Maybe someone can share what he or she sees in the chat box for our. Let's see what you say. Why is it still loading? God damn, son. Uh, okay. Why? Oh, let's see. Okay, I'm gonna kill this and try to download it again. This is an embarrassment. Okay, guys, if you follow the thing over here, you should be able to. Okay, 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 okay. Yes. Wait, what? No. Okay, what did I mess up with? Okay, let's try 13. Oh no. CV2. Is it? No. Uh, let's see. Did I mess up somewhere? Don't think so. I swear it worked a couple of days ago when I did it. This is embarrassing. Okay, this it's all right. Wait, let me check my notes to see if I messed up anywhere. Um, wow. Holy shit, guys. This is not, this is, wow. You know what they say about things going wrong when they go wrong, right? This is precisely one of the situations. It's kind of weird. Let's see if this works. YOLO V4. Let's see if YOLO V4 solves the problem. If it doesn't, then I don't know what else to say. Okay, I think for the sake of demonstration, I will also try to use another image that I have hiding somewhere else. CV traffic. Okay, let's see if this works. Wait a minute, why is it not running properly? Okay, never mind. So let me try a different image. Let me see if something is up. Okay, so YOLO 4 was released not too recently. I guess it kind of messed up the CV library. Again, I think it's okay. We'll see if it works. Okay, let's hope that this works. Okay. Looks like the bounding box isn't working. Okay, fellas. So the idea is actually you should see a box around here. Now, okay, there's no excuses. Give me a second to show you guys what I mean. Okay, guys, this is. Okay, please stick around. Oh shit, wait, partner work. Okay, trying to figure out where the images are. Okay, you know what? Guys, I have no excuse. This is bad. Um, Wait, before that, let me just stop share very quickly, very, very quickly. One moment. I just want to show you guys what to expect when it's done right. So don't leave, okay? I just have a few parting words before we call it evening. So, well, okay. Yeah, don't laugh at me, but this is share screen. Once again, share screen. See, I wasn't kidding when I said I had notes, right? So this is what I was this is like these are the notes I was referring to. And the thing is, if you use the C, right, you can actually draw bounding box around common objects, which is cars over here, cars. And then at the end, the expected output is actually, oh, it's not there. The expected output is actually, there are three cars over here in this box. So I'm not too sure why it didn't work this time around, but I apologize for the hiccup. So that's that. And okay, so I guess that's, yeah, it's just an unexpected hiccup. Should roll with the punches, as my mom would say. Yeah, we've come to the end of the code along. Please don't leave yet. I have a few parting words with regards to your challenge. You might be wondering, Jackie, why did we do these two parts? Like part one was so laborious and you went through all of that stupid thresholding and dilation and differencing thing, right? Um, I hope you guys paid close attention to what I said during the workshop. There are certain things that you should take note of that would be immensely helpful for your work. A few random things I might want to add in no particular order. I wonder to myself sometimes that when you are faced with an image data set, one of the things you should try is checking out the dimensions. Ask yourself whether the images are all the same size. It's important because you don't want to hard code your detectors, right? You don't want to hard code your detectors. You want to ensure that whatever detectors that you code is adaptable to whatever sizes of image there are. And sometimes when someone takes a photo of a piece of paper, he or she may leave shadows on the image. That shadow may or may not mess up your thresholding. Maybe, I don't know. Haha. So it's important to pre-process your images by removing things like shadows. Okay, food for thought. Also, I think that's those two those two hints are good. There are actually a few ways to approach this competition, I must say, but I'm just wondering aloud here in case I get tackled by the organizers for saying spoilers. Huh, right. Is there? Okay, nothing else. Good luck everyone for your competition. So thank you for your attention, and please check out our website. We're gonna remove our free project notebooks tonight. So come grab them while it's fresh and hot. What else? Drop me an email. We will be sharing the notebook that we did this evening once I troubleshoot it with the organizers. Okay, so look forward to that. Other than that, that's it. I think there's nothing else. Let me just take a quick look at the. Wow, I see friends. I see friends reuniting in the chat box. Okay, okay, okay. All right. Let's see. Somewhere says it's hard to start on this for real. Yeah, you need to pair up with people who are working on their own stuff, right? So it's a teamwork. Okay, teamwork makes the dream work. Yeah. Anyway, I hope this is a good learning experience. If possible, go back, watch. Go back, watch this video again, and then see what I was saying in each line. Just play it slowly. Okay, let's see. Yeah, a lot of things over here are all try and error. Once again, a big shout out and thank you to the few great fellas in the chat box helping the other learners. I think this is a very beautiful thing, right? It's a very beautiful thing. I I have hot tears running down my eyes right now, figuratively. Mm. Yep, thank you, Lionel, for explaining everything. Yeah. Okay, cool. So I don't know. I'm not too sure what's the next best thing to do with the organizers. I don't know. Anyway, I'll leave it to the organizers if maybe they okay lah. Well, we'll correspond what's the next step to do. And on this note, I'm done. Thank you everyone for your time. Good evening. Have a good evening ahead. Another thing that I would like to say is this is a team. This challenge is a team effort. Make sure you divide your task accordingly. Okay, divide and conquer. Okay, done.
Right. Big thank you to Uplevel and especially Jackie for giving such an excellent workshop. We hope you have enjoyed it. And of course, Uplevel is a very excellent company. They have free notebooks, as Jackie has mentioned, and that's available until tonight. So go download it, go try it out. And if you're interested, you can always contact Jackie or yeah, you just go browse their website for more stuff.
We have discounts like steep discounts for members of the Stats Society. I think as token of our friendship. Okay.
Hey, I hope you all enjoyed the workshop. Hope you all caught the hints where that Jackie has shared every now and then during this workshop. And also, we have created a Telegram group. In case you haven't joined, you should. And you can ask, you can clarify your problems, your issues about the problem statement, the data, or you can just in general ask if you are trying to start up. If you are a complete beginner, you can ask how to start, what's the right direction. I'm sure people will help out. And do check the program outline often. I'm not going to tell you when's the next time we're going to meet, when's your submission deadline. You have to check the program outline by yourself. I'm sure I've seen a lot of people not checking it. So do check it. And once again, a big thank